Hi guys, so this video immediately follows on from my previous one on labelling right angle triangles. So you will probably see that I'm using exactly the same piece of paper as I was before to actually answer these questions. So I'm going to be showing you how you apply the formula sheet to the question and get the correct answer. So I labelled all of my right angle triangles on this page according to this diagram here. Okay, I always had my hypotenuse and my two shorter sides. So it's already been labelled for me. Like I said, do go back and watch that video if you're unsure about where the labels come from. So the formula sheet does tell me that a squared plus b squared is c squared. So this is where you will see the labelling really helping us. So I'm just going to write that down. A squared plus b squared equals c squared. So I know that if I take a and square it and take b and square it, I get c squared. So let's find out what a is. So if I look to my diagram, I can see a is here, a is 6. It's going to be 6 squared. So look to my diagram, it's going to be, I'm looking for b and it's here. It's going to be 8. So I'm going to do 8 squared. Finally, I'm looking for what c is. You can see it's been called x here. So let's call that x squared. Okay, so I need to calculate these. Now, sometimes you will have a calculator, but in the 2022 series of papers, Pythagoras Theorem has actually been listed non-calculator. So lots of people are going to be a little bit worried about that, but actually I think that's really good news for you because it means the numbers are going to be quite straightforward. You're not going to have to be working out any horrible square roots in your head. Okay, so the fact it is non-calculator is probably a good thing for you. So I'm going to do this first one without a calculator, and then I'm going to just give you an example of one with a calculator because again it could pop up in future papers, but we know it is going to come up non-calculator. So 6 squared, I'm just going to evaluate that, is 36. 8 squared, let's evaluate that, is 64. X squared, I don't know what that is yet, I'm looking for it, I'm just going to write x squared. So I'm going to add these two together, 36 plus 64, that gives me, 100. So 100 is equal to x squared. So I need to do the square root of 100, that is what I'm doing, to give me that just x is equal to 10 centimetres. Okay? So I'm going to move on to a non-calculator one. So again, I've got a nicely labelled triangle. I'm going to write out Pythagoras' theorem again. A squared plus b squared equals c squared. So let's look for what a is. It's going to be 5. So 5 squared. Let's look for where b is. See it's here. It's going to be 7. So 7 squared. And then look for where c is. It's here. We've called that x again, so it's x squared. So I can do these on my calculator, or sorry, I can do these without a calculator, but any future calculations will need my calculator. So 5 squared gives me 25, 7 squared gives me 49, and that is equal to x squared. I'm going to add these two together to give me 74, which is equal to x squared. And then I'm again going to have to square root. Now, I've got no idea what the square root of 74 is. I could kind of have a bit of a guess, but there's no need. I've got the calculator. So I'm going to just type in square root of 74. It's going to give me, use my S to D button, 8.6. So it's going to be 8.6 centimetres. And I'm just going to say what degree of accuracy I've gone to. Let's go 1 decimal place. That rounds quite nicely. Okay, so those are kind of the two classic types where you're given the two shorter sides here, and you're asked to find the hypotenuse. But you could quite easily be asked to find one of the shorter sides. Now, that doesn't really make it any more difficult. It just adds one extra little step, and it's not that hard a step, assuming you have labelled correctly. So, I'm just going to write out Pythagoras' theorem again. This is on the formula sheet. A squared plus b squared is c squared. So let's look for what a is. I can see, well, I've labelled a here. That's going to be 5. So 5 squared plus b squared. Let's look for where b is. Right, well, I've said b is here, and that's y. so I can just write y squared. Let's look for where c is. It's down here. It's going to give me 13 squared. So if I go through and, just like I did up here, evaluate both squares the best I can, I'm going to get 25 plus y squared equals 13 squared is 169. So then I can rearrange that. I can take 25 away from both sides to give me y squared equals 144. Okay, so hopefully we can identify that as a perfect square. Y squared is 144, y is equal to 12 centimetres. Okay, that is something that could come up on a calculator. Okay, moving on to a calculator example. Got a nicely labelled right angle triangle. I'm going to write out Pythagoras' theorem. A squared plus b squared equals c squared. I should say, guys, it might be a nice idea if you're feeling confident to pause the video now and have a go and see what the answer is. Or if you're not feeling that confident, just watch along anyway. So, A, I can see, is already labelled as 3. So I'm going to have 3 squared plus, let's find where B is, it's down here. So that's going to be z squared is equal to, C's here, 10 squared. I'm going to evaluate that the best I can to give me 9 plus z squared equals 100. Let's rearrange to get it so I've just got my z squared by itself. That gives me z squared equals 91. So on my calculator, I'm just going to type in square root of 91. I've come up with square root of 91. Let's press S to D, and I can see 9.539392014. Let's round that to 9.54. Again, just stating what the degree of accuracy is, 2 decimal places. The question will probably tell you, but sometimes you'll have to make a judgment call for yourself. So, one thing I do want to add before I go. The first question I did up here, and the third question, they are some very specific examples of Pythagoras' theorem. And they're ones that don't need a calculator. The reason they don't need a calculator is because if I square this, and add them together, it gives me a perfect square. It gives me 100. Same with down here. If I square this, square 5 and square 12, and add them together, it gives me 169. That's a perfect square. So that is a really specific example. Those 3 numbers are specific examples of Pythagorean triples. So some people do memorise these. You don't have to though, you can probably work them out for yourself in the exam. So the most common ones you are given are 3, 4, and 5, because if you do 3 squared plus 4 squared gives you 5 squared. I'm just going to prove that. 3 squared is 9, 4 squared is 16, 5 squared is 25. 9 plus 16 is 25. The other quite common one that you see is 5, 12 and 13, okay, as we just saw in that question 3, because 5 squared plus 12 squared equals 13 squared. 25 plus 144 equals 169. Okay, so adding these two together gives me 169, squaring 13 gives me 169. So it's not just those specific 2, those are the main ones. However, any multiples of these could be, well, they are Pythagorean triples. So for example, I could double 3, 4 and 5. So 3 times 2, 4 times 2, 5 times 2, they are all Pythagorean triples. 6, 8 and 10. They are Pythagorean triples. 6 squared plus 8 squared is 10 squared. 36 plus 64, 100. So you don't just have to multiply by 2, you can multiply by 3. Straight away I can tell you 9 plus 12, 9 squared plus 12 squared is equal to 15 squared. Okay, there's any number of Pythagorean triples based just on that, based on this. So as another example, I could have 10 squared plus, just focus that, 10 squared plus 24 squared is going to be equal to 26 squared. So if I just type that into my calculator, so I know 10 squared is 100, 24 squared is 576, and if I work out what 26 squared is, it should give me 676. Yeah, it does. So these are the main two to remember. Okay, remember Pythagoras' theorem is on the non-calculated paper this year, so the chances are it's going to be based on one of these two or a multiple of them. Okay, so just remember 3, 4 and 5, and 5, 12 and 13. If you square the smaller two, add them together, you get the bigger one squared. So I hope this video has been useful. I'm going to be moving on to SOHCAHTOA in my next video. See you later, guys.